Welcome to Sundar's lecture. And in this lecture, this is lecture number 25. In this lecture, we are going to see star delta conversion. See, this topic comes under that resistors connected in parallel and series. We have missed this topic, right? So, conversion of star to delta and delta to star is very important. See, I will tell you the application of this conversion because uh, at sometimes in circuits you cannot simplify this star connection with the easy method. So what we do, uh, we will convert this star connection to the delta connection. That we are going to write the expressions for star to delta conversion as well as delta to star conversion. That is what we are going to see in this particular lecture. So, what are the topics we have seen in the last class? So, in the last class, we have completed the dependent sources problems, right? So, dependent sources problems where we have applied both KCL and KVL at the same problem. We would have got a clarity about applying KVL, KCL, and what is dependent sources, how we need to approach the dependent sources problem, and all those kind of things. This is entirely a different topic. And after this, we are going to start new topics. So that new topic, which is nothing but it is AC circuits. So whatever the things we have seen in the up to 24th or 25th lecture, we have concentrated only in DC circuits. So in the next lecture or maybe the next lecture, we will start AC circuits. Anyhow, see, so what is the star connection and delta connection? We know this one, right? This is star connection and this is delta connection, or otherwise this star connection may be also called as Y connection, because you see it is like inverted Y, right? Y shaped this symbol. So we always call this is a star and this is delta connection. So so what is that? We can also write this as like this: star connection to delta connection. We always write like this. So so I will tell you how to apply this one, where we need to apply this. So we will take an example, a problem to solve this star to delta connection. So there you can easily understand why we need to write the expression for star to delta conversion in resistor connected circuits, right? So first of all, we will try to simplify the simplify this circuit to write expressions. You see, this A, this B, and this C should not be changed. You see, this one is A, this one is B, and this one is C. While you are taking a problem, there also you have to write this is A, this is B, this is C, whatever the symbols they have given in the questions. But we are going to create the formulas for this connection A, B, C. This should be A, B, C, as well as this should be RA, this should be RB, and this should be RC, and also this is R1, this is R2, and this is R3. These are all mandatory things. These are all mandatory things. You have to write the formulas while applying the formulas. You have to take the resistors in this manner. See, in problem they might have given you this is R1, this is R2, this is R3. No. For example, this is 5, this is 4, this is 3. 3 has to be R1, like that. So I will tell you. Anyway, I will tell you. See what we need to do now. Let us we compare these 2 points now. So this is A and this is B. So you see, if these 2 points, this is A and this is B, what is the equivalent resistance? These two are connected in series, right? One end is only connected. You don't see this C resistor. You see A and B, only A and B. So if you see this, these two are connected in series, right? So these two are connected in series. So I will write here R R A B, equivalent resistor connected between RAB, right? So RAB, which is nothing but what? R small a plus R small b, because these two are connected in series. So what you will get here? So this will be RA plus RB, right? So now you see, same thing. What is the equivalent resistor connected between these two? You should not tell that is R2. Why? Because you see this end and this end is connected with these two resistors also, right? These two resistors are connected in series. See, one end is only connected, so these two are connected in series, so that will be R1. So you see how these two resistors are connected. I will draw here anyhow. Maybe we will take a new page so that we can easily understand. See this one. I will draw this one anyhow. See, this is one resistor, and you have two resistors connected. You see, two resistors are connected in series. What is the equivalent resistor between these 2 points? By these two resistors, that is R1 plus R2, right? That is R1 plus R2. So I will write. I will draw like this. So this is already R2. This is already R2. This is R1 plus R3, right? R1 plus R3. Now you see these two resistors are connected in parallel. So what you will get? So if it is parallel, what we have seen, 1 by R1 plus 1 by R2, that should be equal to 1 by RP, right? We know this. We have already seen. So if you simplify this, you see, if you want to get what is RP, then it should be what? R1 plus R2, and this should be what? R1 into R2. This is the simplification. You just simplify this, you will get this. So like that, if you take this problem, this is point A and this is point B. This is point A and this is point B. If you simplify these two, what you will get? So RAB should be equal to, what you will get? So you have to add all these resistors, R1 plus R2 plus R3, and in the above circuit you will get R2 into R1 plus R3, right? So this is RAB, right? This should be RAB. So how you can write this as this one? Simply you add these two resistors and write it in the denominator. You multiply these two resistors and put it in the numerator. That is the simplified way to write the parallel connected resistors, right? So you have to add two resistors and put it in the denominator, and you multiply these two resistors, put it in the numerator. That will be the final equivalent resistors connected in parallel. So what we can do right now, for this RAB, we can write it as, that should be equal to, this is divided by, between these 2 points, right? Between these 2 points. So then obviously R1 plus R3 will come here. So this denominator will get R1 plus R2 plus R3, and what you will get? R2 multiplied with these two added resistors, right? So this will be R2 into R1 plus R3, right? Simple. We have written what is the resistance between RAB by comparing these two. Like that, what you do now, write the next one, RAC, between RAC. I'm just writing here, between RAC. Between RAC, what is this one? RA plus RC. So this will be RA plus RC, right? That should be equal to, you see, between RAC, you just divide this one. So between RAC, these two resistors are connected in series, and this is connected in parallel with this R1 resistor. Combination of these two will be connected in combination with this. What we will get? Obviously, denominator will be addition of these this R1 and R2 plus R3, right? R1 plus R2 plus R3, and what you will get in the numerator? R1 multiplication of these two added resistors. So this will be R1 into R2 plus R3, that we will get here. So next one, we need to write what is RBC, right? RBC. So what is the resistors connected between RBC here? You see these two are connected in series. So you can write it as RB plus RC, that should be equal to, you put a divide now. You see between these 2 points, RBC, between these 2 points, R3 is there, and these two are connected in series, R1 plus R2. So in the denominator, obviously you will get R1 plus R2 plus R3. There is no difference. But here you see R3 should be multiplied with these two added combination of resistors, right? So this will be R3 into R1 plus R2. That's all, right? This is expression number 1, and this is expression number 2, and this is expression number 3. That's all, right? So now what you do, you just add, you just add, 1 minute. So you just add expression number 1, expression number 2, and expression number 3. You just add all these three values. So what you will get, RA plus RB plus, you see there are two RAs, there are two RBs, and there are two RCs. Right? If you add all these, what you will get? What you will get? Obviously, you will get 2 into RA plus RB plus RC, right? You will get like this. That should be equal to, and if you add all these things, see all denominators are same, then obviously what you will get, this will be denominators, R1 plus R2 plus R3, all the denominators will be same, right? So you see, you just add all R1 R2 plus R1 R3, right? So I will write here anyhow, I will write this one. So you just add these things. So R1 R2 plus R2 R3 plus this multiplication. Then you add these two. Sorry, multiply these two. R1 R2 plus R2 R1 R3. So R1, I'm just writing here, R2 plus R1 R3. I don't have space. So what I will do, I just rough it out this one. I just rough it out this one. So then plus, see, I will write down. Afterwards. See, this one is R1 R3 plus R1 R2 R3, R1 R3 and R2 R3. So this will be R1 R3 plus R2 R3, that this whole divided by R1 plus R2 plus R3, right? So you will get like this. Now you see this one. See, this is R1 R2, you have another R1 R2. R2 R3, you have another R2 R3. And you see this one R1 R3, you have another R1 R3. So what I can write this, so this expression can be written as 2 into RA plus RB plus RC, that should be equal to, this will be R1 plus R2 plus R3. There is no difference, but here everything R1 R2 R2 R1 R2 is there, R2 R3 is there, R3 R1 is there. Everything is, we have two terms, right? So what you will get here, 2 into R1 R2 plus R2 R3 plus R1 R3. That's all. So this is the term. So what you do here, you can cancel these two expressions, right? This is very simple now, and make this as expression number 4. So this is expression number 4, right? Now what you do now, you can subtract expression number 4 with expression number 1. So I will write here expression number 4 minus expression number 1. So what you will get, you see why we are actually doing this. If you subtract these two, you have to subtract this left hand side with this left hand side and this right hand side with this right hand side, right? So if you subtract these two, RA plus RB plus RC minus RA minus RB, so RA and RB can be cancelled out, you will get RC, right? Expression for RC, you will get. So what we can do, you just subtract this one with this one, right? So if you subtract this one with that one, that means 4 minus 1, 4 minus 1. RA will be cancelled out, RB will be cancelled out. Only you will get RC. Only you will get RC is that. That should be equal to, you see, denominator here it is R1 plus R2 plus R3, as well as here it is R1 plus R2 plus R3. So what we can do, if you subtract these two terms, both the denominators are same. So if both the denominators are same, you can directly write it as a single denominator R1 plus R2 plus R3, and you have to subtract the numerator terms. In numerator, you just multiply these two terms and write it down. See, this is expression number. First, you have to write the expression number 4. So I will write here. See, R1. I'm just writing the same expression here, right? So R1, R2 plus R2, R3 plus R1, R3 minus, you see, this is minus, right? This, because expression number 1 has to be minus, right? So this one will be minus R1, R2 minus R1, R2 and then minus R2, R3 minus R2, R3 minus R2, R3. Now you see this R1, R2 plus R1, R2 minus R1, R2 will be cancelled out, and minus R2, R3 and R2, R3 will be cancelled out. And finally, you will get RC equal to R1, R3 divided by R1 plus R2 plus R3, right? So this is the final expression. So this will be marked as 5 and this will be RC, right? And this will be RC expression. Like that, what you do, I will write it here. Similarly, what you do, you minus expression number 4 with 2. Expression number 4 with 2, this expression 4 with 2. If you minus 4 with 2, RA, RC will be cancelled out and you will get what? RB, right? Obviously, you will get RB. So, RB will be equal to R1 plus R2 plus R3. So, you will get R2, R3 here. So, this is expression number 6. And similarly, what you do, you just subtract expression number 2 with minus expression number 3. So, what you will get here, RC will be equal to the, if you minus these two expressions, then sorry, not RC, you will get RE, because you see RB, RC is there, RB, RC is there, both will get cancelled each other. So RA, you will get the expression for RA, that should be equal to R1 plus R2 plus R3, and in the numerator you will get R1, R2. So this will be expression number 7. And you try to understand, we have got RA, RB, RC. Now you just try to understand this expressions. See, what is RA? In star connection between these 2 points, that is nothing but RA. And what is R small b? That is with this resistor. And what is RC? RC, which is nothing but this resistor, right? And what is the combination you got? Everything is 1, 2, 3. 1, 2, 3, which means what? This is delta connection. This is nothing but delta connection. Everything we got in delta connection in combination with the star connection, right? RA, for RA, you will get what is the combination of delta connected resistors. So that is why this connection, which is nothing but this is nothing but star to delta conversion, or you will get star connection. Both vice versa connections we are going to derive anyhow. We are going to get R1, R2, R3 in terms of RA, RB, RC. Both, vice versa. That we will see in the next class. We will wind up with this in this class, and we will see the what is the expression for R1, R2, R3 in terms of RA, RB, RC. Then we can apply this with an example problem where delta to star conversion or star to delta conversion can be performed. Thank you. We will see in the next class.